no plus two, just x squared. So on the last page of today's notes, try this two should be f of x equals x squared. Because here we're gonna let f of x be x squared plus two. And what are the, I said that A was 0, I think, but what was B? For example 2.
4.
So let's sketch this really quickly. Don't feel discouraged if your graphs are not beautiful like mine. Thank you, thank you. When I was a student, my graphs, all of my work was beautiful. And then I started teaching. Okay, so we know that this is the point 0, 2, because if we put 0 in for x, we get 2. And let's put 2 more points. Let's put -2 and 2. If x is -2, we get so if x is -2, we get -2 squared plus 2. What is -2 squared?
4.
4 plus 2?
6.
So this is the point -2, 6, and if we plug in +2, we get 2 squared plus 2, which is also
6.
6, yay. And so you can see that the area that we're looking at is not quite on our drawing. It's this area between x equals 0 and x equals 4, and it runs up. And what is the point up there? 4 squared is
16.
plus 2?
18.
Okay, good. Can we use geometry to find an exact sum here? An exact area? Exactly right. So let's see. We started out by saying we need delta x which is b minus a over n. B is 4, a is 0. So we get 4 over n. And we're almost always going to multiply by I to get our x of I. So that f of x of I is 4 over n I squared plus 2. Can y'all help me with that? 4 squared?
16.
N squared? I squared?
I squared.
Plus 2. So now we've got f of x. Let's go ahead and multiply f of x times delta x. So we've got 16 over n squared times I squared plus 2. And what did we say delta x was?
4 over n.
And somebody help me at this stage. What do I do with the 4 over n?
You multiply it by 16 over n squared. That'll be 62 over
Six-
n cubed.
Over
N cubed.
64, 4 cubed is 64. But that's okay, and we have I squared, and then what about, 2 times 4 over n?
It'll just be 8 over n.
Groovy. And now we can use the summation. So we have the sum I equals 0 to n f of x sub I delta x is equal to sum I equals 0 to n of 64 over n cubed I squared plus 8 over n. Groovy. Are you thinking or are you perplexed, Justin?
A little bit of both. I'm
Can you
writing.
ask a question?
No, I cannot. I'm just writing stuff down.
Okay, that's okay. So, what do we do here? What can we do?
We can separate the sum.
Good. So we have the sum as I runs from 0 to n of 64 over n cubed I squared plus the sum as I runs from 0 to n of 8 over n. Now what?
So now we're gonna take out the 64 over n cubed and multiply it by the sum of I squared. Plus 8 over n times the sum of 1.
Good. So we have 64 over n cubed times. What's the sum of squares? You don't have to memorize them, but I do want you to be able to find them.
It's n times n plus 1 times 2n plus 1 over 6.
Beautiful. And what is the sum, oops, I runs from 0 to n of 1.
It's just n times, or is it n times c, but yes.
Groovy. And is there anything you want me to divide out before we do the next step?
First, we could separate the n squared, so we could do 1 over n, 1 over n, 1 over n.
But
And
can we
also-
do anything before we do that? Can we simplify anything?
We could, if we take 8 over 1 times n, we could take out the n.
Yeah, good. So here we'll have plus 8. And what about in the first part? Can we move the constants, the coefficients to the front, to the left? In other words, can we move 64 over 6 to the left?
Yeah, that's what I was going for.
And can we reduce that? If we're gonna move it to the front, can we reduce?
Yes, by 2.
Yeah, sure.
We have 32 over 2.
And that's what we're gonna leave it as for right now. So we have 32 over 3, 1 over n, 1 over n, 1 over n,
Plus 8.
n plus 1, 2n plus 1 plus 8. By moving the 6 to the front or to the left, it makes this distribution mess a little bit easier, yeah. That doesn't show up very well, so we're gonna. Let me know if this color also doesn't show up. Does this show up?
Yeah.
Okay, so we've got 32
Over 3.
over 3. What am I gonna do with the first one over n?
We're gonna multiply it by n and cancel it.
Good. And what am I gonna do with the second one over n?
Distribute it onto n plus 1. So we'll have n over n and 1 over n.
Groovy. And the third.
Distribute it amongst 2n plus 1.
Groovy. 2n plus 1 over n plus 8. N over n, like it said, is 1. N over n, so the second parentheses becomes 1 plus 1 over n. And the third, I'm gonna write it in 2 steps. We have 2n over n plus 1 over n. So let's just rewrite. The first coefficient is 32 over 3. Do I need to write the 1? This one right here.
No, you don't.
Okay, groovy. So 1 plus 1 over n. And what am I gonna write in that second?
2 plus 1 over n.
All right. Are we ready to look at the limit?
Yes.
Yeah. Sure enough. So we have the limit as n goes to infinity of 32 over 3, and that just doesn't show up, or doesn't mark well. 32 over 3 times 1 plus 1 over n times 2 plus 1 over n plus 8. Can we go back in your minds, when we were looking at limits 100 years ago when y'all were in Calculus 1, could you take a product and do the limits individually and multiply the answers? Yeah, unlike almost anything, we can do that. So we could think of it as the limit as n goes to infinity of 32 over 3 times the limit as n goes to infinity. Let's just write it down. So we have 32 over 3 times the limit as n goes to infinity of 1 plus 1 over n times the limit as n goes to infinity of 2 plus 1 over n plus the limit as n goes to infinity of 8. So we just sort of distributed the limit. The limit of a constant is just the limit of 5 as n goes to 1,000,000 is still just 5. Yeah, so the limit as n goes to infinity of 32 over 3 is just 32 over 3. The limit as n goes to infinity of 1 plus 1 over n is one. Good. I'm gonna write 1 plus 0, just so to remind us that the 1 over n went to 0. And the limit as n goes to infinity of 2 plus 1 over n.
2 plus 0.
Good. The limit is n goes to infinity of 8.
8.
Ruby? One times 2
2.
times 32
64 over 3.
plus, and I'm gonna, because I'm weird, I'm gonna write 8 with the denominator of 3. That's 24. That's 88, is that right? Oh, square units. Three in the denominator is exact 0.33333. As many times as you write it is still an approximation. So this is exact, and then you can approximate. Any questions? Okay, I want y'all to try this too. How are we doing? Oh, we're doing okay. And I'll get that later.